Hello everyone and welcome to your walkthrough for worksheet 6A and in class 1. This is for MAT121, the college algebra that is a semester long, and we are in week 10, I believe. So like I said, we're going to go over two worksheets today. One of them is the one that says in class 1 on the top, and the other one is 6A. So let's start on in class 1, and we're going to start with number 1 on that worksheet. So for these, all they want us to do are find the vertical and horizontal asymptotes, and we don't really need to graph these in order to find these. Okay, so looking at number 1, the first thing that I'm going to find for this is the vertical asymptote. So the vertical asymptote is basically a line that our graph is going to get infinitely close to, but it will never ever touch. Well, this one's really easy to find. All we do is we look on our fraction and figure out what x could I plug in to make this 0. So for the first one, on the bottom we have x minus 5. So if we plugged in a positive 5 for that, that would screw up the whole thing. So x equals 5 is going to be our vertical asymptote for this one. Okay, now finding the horizontal asymptote is a little tricky. We have to use this guide right here. And basically what it says is if you look at the degree of the top and the degree of the bottom separately and then just compare them, there's 3 different situations that you can have. First situation is the degree of the top is less than the bottom, and that is kind of common. So if that ever happens, you're just going to have a horizontal asymptote at y equals 0, no matter what the numbers are in front of it. If the 2 degrees are the same, meaning on top we have like an x squared and on the bottom we have an x squared, what we look at are the coefficients for the x squared. So in this example, there's a 2x squared on top and a 3x squared on bottom. Since they're both x squared, we look at the 2 and 3 and we just make a fraction. So it's going to be at 2/3. So we just look at the 2 numbers and that's where it is. And then the last situation is when the degree of the top is bigger than the bottom. So in green here, we have 2x cubed up top, and on bottom we have 3x squared. Well, if that happens, you're not going to have any horizontal asymptote. What you will ultimately have is an oblique asymptote, and we're not going to talk about those for a few worksheets, so you don't need to worry about it quite yet. But you just put no horizontal asymptote for that. Okay, so on this one, on number 1, there is a degree of 0 on top because we don't have any x's. On bottom, we have a degree of 1 because there is an x and it could be raised to the first power if we wanted to write that 1 in there. So since the top degree is less than the bottom degree, we're going to say we have a horizontal asymptote at y equals 0. And I just realized I flip-flopped those, so y equals 0 should be your horizontal asymptote on bottom, and x equals 5 should be the top one. So just flip-flop those on your paper. Okay, number 2. What we have here is, first thing we got to do is figure out what is going to make the bottom 0. So we have 2x plus 1. What's going to make that bottom 0 is negative 1/2, because half of a 2 is a 1, and if we make it negative, it'd be negative 1 plus a 1 would be 0. So we get x equals negative 1/2, and that's going to be our vertical asymptote. Our horizontal asymptote, well, the degree of the top is a 1 because we just have an x. It's not squared or cubed or anything like that. And the degree of the bottom is 1 because we just have an x. It's not squared or anything. So since those two match, we look at the coefficients. Well, in front of the x on top, we have a negative 3. In front of the x on bottom, we have a positive 2. So negative 3 over 2 is what we get. So just negative 3/2. And that's what we put for our y. So once again, I flip-flop these. The horizontal asymptote, the x equals negative 1/2 should be on the top line, and y equals negative 3/2 should be on the bottom line. So just switch those. Okay, skipping down, let's look at number 11. So number 11, we're going to do exactly what we just did. We're going to find a few extra things, and then we're going to graph these and find the domain and range. So horizontal asymptote, once again, is going to be the vertical asymptote is going to be what makes the bottom 0. So on this one, x equals 4 is going to be our vertical asymptote. So that's how I got that thing in red. The blue is going to be, well, the top degree matches the bottom degree. So we look at the coefficients. Well, there's nothing in front of the x, so there's really a 1. There's nothing in front of the x on the bottom, so there's really 1. 1 divided by 1 is a 1, and that's how I get that horizontal asymptote of y equals 1. Okay, my x-intercept, well, we got to figure out where it crosses the x-axis. Well, the spot where that happens is when y equals 0. So really what you're doing for that ultimately is figuring out what makes the top of the fraction 0. But the way we get that is we say f of x equals 0. So the whole left side is 0. We multiply both sides by x minus 4. It cancels out. And so that's why I'm solving what makes the top 0. So what number plus 1 is 0? Well, that's going to be -1. So this is going to cross the x-axis at -1. And that's how I got that green dot on my graph. Y-intercept is basically you just plug in zeros for all the x's. So we get 0 plus 1 up top, 0 minus 4 on the bottom. So 1 over -4 is -1/4. And so that's where it crosses the y-axis, and that's how I got the dot there. So now from that, we got a couple asymptotes, and we got a couple points where it's going to cross the x and y axis. So we don't really have a lot to graph off of. If that ever happens, you want to make a chart and just plug in some values, and that's what I did here. I plugged in a 2, a 3, a 5, and a 6. You can plug in any x's you want, so it doesn't make sense to plug in, a ton of negatives or a ton of really big numbers. I just picked ones that I wanted to see, and that's how I came up with this chart. There is some strategy to that, so once you do a bunch of these problems, you'll be able to pick better x's. But I picked 2 and 3, and then 5 and 6. So a couple on the left of the red line and a couple on the right of the red line. So when you do that, you come up with these values, and I put them on my graph. So that's how we come up with the graph. Now, for the domain, all we have to do is figure out what x's work, and then for range, we've got to figure out what y's we're getting out. So for domain, it's going from -infinity all the way over on the left, all the way up to this +4, and it's not touching, so that's why I have a soft bracket. The u means and then the right side of the graph, it starts at 4 and goes to infinity. So 4 with soft bracket to +infinity. That's how I get the domain. Now range, we're looking at our y's. So it's starting way down on the bottom at -infinity, going all the way up to 1. It's not touching there, so soft bracket at 1. And starting at soft bracket 1 again, going up to infinity. So that's how we get that range. Okay, let's skip down to something a bit more interesting. This is number 13 in class 1. So number 13 are horizontal asymptotes. And really, you're going to switch the blue and the red. I flip-flop those. I kind of did that throughout this whole worksheet. So horizontal asymptotes, vertical asymptotes are what makes the bottom of this fraction 0. So we're going to get x equals -3 for x plus 3, and then x equals 4 for x minus 4. So we have -3 and 4, and on my graph over there, I graphed 2 vertical lines in red at -3 and 4. My vertical asymptote, well, up top, if you foiled those, you would get an x squared as your lead term. On the bottom, if you foiled those, you would get an x squared as your lead term. So x squared over x squared, those degrees match. They're both being squared. So now we look at the coefficients. Well, there's going to be nothing in front of the x squared up top, nothing in front of the x squared on bottom. So 1 divided by 1 is just 1. So that's how I got the blue horizontal y equals 1 line. Okay, so now x-intercepts. Once again, I said it's what makes the top of your fraction 0. So in this case, it's going to be -6 and +2 for those 2 parentheses up top. So I put a dot at -6 and I put a dot at +2. Y-intercept is what happens when you plug in 0 for x. So if you do all that, you're going to get 6 times -2 on the top of this fraction. That's going to be -12. On the bottom, 3 times -4 is going to be -12 on the bottom. -12 divided by -12 is just 1, and that's how I got the y-intercept of 1. So I have a couple dots, and I made a chart here, and I plugged in -4 because that was on the far left side. I plugged in -1, +5, and 6. And like I said, there's a strategy to that, so pick points that make sense for that. So if you do all that correctly, you're going to get this graph right here. Now, one thing that is kind of peculiar on this is it does cross the horizontal asymptote. And you might say, well, hey, I thought I was supposed to get infinitely close to that line and never ever cross. Well, sometimes it does, especially if you have a middle section like that. So if it does cross, don't be, too stressed out about it. It does happen occasionally. Okay, so for the domain on this, we're going to have three sections: the far left, the middle, and the right. So on the left, we're going from -infinity all the way up to that -3, and we're not crossing it. Then we're starting at -3, and we're going to +4 and not crossing. And then we start at 4 and go to infinity, and that is our entire domain. Range is quite a bit simpler. The reason it's so simple is because we actually crossed that asymptote. And since we did that, it's just going to be -infinity all the way up to +infinity because it's defined at every point there. Okay, so that is it for number 13. Okay, so let's look at worksheet 6A, and this is going to be pretty much the same thing we were just doing. Yeah, it's going to be exactly the same thing. There are a couple tricks on this one, but I'm only going to do 3 problems on this. So there's a total of 6 problems already. So looking at number 1 on worksheet 6A, they don't really ask us to find all those things, but I think it's a really good idea to do that anyways. So the first thing I start off with is the vertical asymptote. Well, vertical asymptote in this one is what makes the bottom 0. So 3 minus 3 would be 0. So we say x equals 3, and that's how I got the vertical red line. For the horizontal line, we look at the degree of the top, degree of the bottom. They both match, so we look at the coefficients. 1 divided by 1 is just going to be 1. So that's how I got y equals 1, or this horizontal blue line. Okay, so from there, I found my x-intercepts and my y-intercepts. X-intercept is what makes the top of this 0, so that's going to be top of this fraction 0, so that's going to be -2. We look at what happens when we plug in 0 for x, so you're going to get 2 over -3, or -2/3. So that's how I got the y-intercept. And then I plugged in a couple points into a chart over here. I did 1, 2, 4, and 5. So I just picked a couple to the left of the blue, red line and a couple to the right of the red line. Once you do all that, this is the graph that I got. And the domain for this is just going to be -infinity up to that +3. And then starting at that 3 going to +infinity. Really similar for the range, -infinity all the way up to 1. And then 1 to infinity on the top. So that is the entire thing. Okay, let's look at number 2. Number 2 is similar to what we just did, except there is a trick to this. The trick to this is you got to factor out the bottom of this fraction before you even begin. The reason we factor that is because it's a quadratic and it's going to have 2 x's that make it 0. So when I factor the bottom of that, I got x minus 2 times x plus 1. That means I'm going to have 2 vertical asymptotes. One is at x equals 2 and the other one's at x equals -1. So that's how I got these 2 red vertical lines. The degree of the top is less than the degree of the bottom, so that means we have a horizontal asymptote at y equals 0, and that's the blue line I drew. I did some intercepts and I did a chart, and so I ended up getting this graph. The domain has 3 parts, -infinity up to 1, -1 to 2, and then 2 to +infinity. And then range, since it crosses that horizontal asymptote, it's just going to be -infinity to +infinity. It's pretty simple on that one. Okay, let's skip down. This is the last one I'm going to do for this video, to number 4. Number 4, we have to factor the top and the bottom of this fraction. So when we do that, we get 3x minus 3 up top times x plus 2 up top, and then x minus 4 times x plus 3 on bottom. So for this one, you get a very, very strange graph. There's a couple weird features to it. The vertical asymptotes are at 4 and -3, because that's what makes the bottom 0. And the degree of the top matches the degree of the bottom. So 3 over 1 is just 3. So that's how I got a horizontal asymptote at y equals 3. Now, I plugged in a couple extra points, and they're here on my chart. And you get some ugly fractions, but that's what you get. The domain on this is pretty easy. It's negative infinity up to -3 and -3 to 4, and then 4 to positive infinity. Now the range is very, very difficult on this one. The reason for it being difficult is because there's a gap in between the peak of that middle section and the trough or the lowest point on the left section. Now the left section is very strange because it gets infinitely close to this red line, and then when it gets to the blue line, it doesn't get infinitely close to it. It crosses it, and then it gets infinitely close to it from the bottom. So there is like a gap in between there, and what you would have to do is use a calculator to figure out what the highest point is on the parabola in the middle and the lowest point of your trough on the left is. I'm not going to ask you to do that on any test or quizzes or anything like that, so I left it blank for you here just because I wanted to show you that you don't have to find that. Okay, so that is it for worksheet 6A in class 1. I haven't decided. I am probably going to collect in class 1, so make sure you complete the rest of that worksheet and then just work through the rest of the problems on 6A. Both of these are kind of the beginning of this chapter. This chapter does get quite a bit harder with these graphs, but this is kind of the beginnings of it. If you have any questions on this, feel free to email me or just ask me in class when you see me. But that is it for these 2 worksheets. So like I said, email with any questions, and I will talk to you later. Thanks a lot. Goodbye.